Okay, so I have uploaded this note on artificial seed. But before we start this note, do you know what it means when I use the word somatic embryo? Somatic embryo. If I use the word somatic embryo, I'll just take it that you don't know. No, even if you know, let's take it that you don't know. Let me simplify it for you. Remember in the classroom, when we met each other, I told you that plants are the only organisms on earth that can regenerate into a new plantlet when we grow them in the laboratory. So suppose you cut a piece of the leaf and you grew it in the media, no? Then it developed roots and then shoots, no? And into a plantlet. So that leaf, that piece of leaf that you took, that is your somatic embryo. You get it? Or if you took a piece of a stem and then you grew it in the media, you know, that agar semi-solid media, then it developed roots and shoots. Then you transferred it into another pot and grew it. So that stem which you have cut is your somatic embryo. Okay. So neither we took a seed, neither we took an embryo, nothing. We just took any part of the plant. Okay. And it behaved like an embryo where it grew into a full individual. No. So even if you take a piece of the anther, no, if you want to grow a haploid plant, so you cut a piece of the anther, then you put it or you inoculated it into the liquid media, semi-solid media, then you uploaded, then you transplanted it into, you know, it got the roots and the shoots and you transplanted it into the soil and it grew into a whole plant. So that anther which you cut and you put, that became your somatic embryo. So your somatic embryo could be haploid or diploid, okay, depending from which part of the plant you took. Okay, so do you know what it means by somatic cells and vegetative cells? Vegetative cells are your sperm cell and your ovum cell. No, these are the vegetative cell. When they fuse, they give rise to the embryo, then the then the zygote, and it becomes into a fully developed individual. But if you take from any cell, suppose you take from my skin, okay, the cells of my skin, that is my somatic cell. Then if you took the cell of my ovum, that is your vegetative cell, okay. So the cell of my skin, okay, my hair, my eyes, my lungs, my kidneys, my intestines, all these are somatic cells, okay. Germ cells or vegetative cells are only the sperm and the egg. So I think it's clear when we say somatic embryo means any part of the plant. It could be the anther, it could be the sepal, it could be the petal, it could be the stem, it could be the branch, it could be the leaf, it could be a flower bud, it could be the root, okay, any part other than the, yes, I think you have got it, other than the egg cell or the pollen grain, okay, those are your somatic embryos, okay. So other than the pollen grain and the egg cell, all the other part of the plant is this, it can function as a somatic embryo. Okay, so these somatic embryos, okay, so I cut a piece of the leaf and I put it on the agar media, no? So they are not protected by anything, no? Do they have a seed coat? You know, like imagine an orange seed, you've all eaten an orange, it has a seed coat, a white color seed coat, no? So does this leaf, this somatic embryo, does it have a seed coat? No, it's just a leaf that I cut and directly I put it. So now you understand the first line when you read this sentence here. Okay, so here we say that somatic embryos, they are not covered by a seed coat, okay, and they can get contaminated by microbes, okay, they can get contamination from the air by the fungus or the bacteria that's in the air, and they will dry out, okay, they will desiccate. Okay, so why, now you are understanding, why the in nature seeds is enclosed by a seed coat, by a seed covering, so that they don't dry out. No, so you just try opening apple seed or a orange seed, you will feel that the seed inside, that ovule inside is wet and spongy. No, it's wet, it's not dry, because the seed coat is protecting the liquid, okay, from drying out. So these artificial seeds, okay, these somatic embryos, it's just a piece of a leaf or a petal, or a sepal, whatever. It's just a piece of a leaf and it's not covered by a seed coat. Okay, and directly we put them in the media and directly we grow them in the soil. So when we want to create, why we want to create an artificial seed is because we want these somatic embryos, okay, these parts of leaf or stem or whatever, we want to cover them, or we want to encapsulate them in a protective sort of capsule, like we want to encapsulate them so that we protect them from the bad effects of nature, like drying and all, damage or infection by bacteria and all. So we want to protect them and they can be behaving just like normal seeds, okay, because they will have this encapsulation, they will have this protective layer around them, and we can store them as natural seeds, okay. We can store them and they will behave just like your normal seed, okay. Like for example, the malarial drug, okay. So we contacted the Amazon rainforest, some scientists there. We said, please send us some somatic embryo. So from the Amazon till India, you just think from Brazil till India, how far? How many kilometers? Thousands, no? And if it goes by ship, then by plane, then by train, no? Then by car, then by truck, then that delivery man. Imagine how much it will dry out, how much it will get infected. So simply that cinchona plant, Cinchona plant, which will produce the quinine for the malarial drug. So they have cut small parts, okay. They've cut small pieces of leaf, small pieces of a stem or small piece of a petal or a sepal. Then they encapsulate it, they cover it in some sort of a gel, okay. Make it behave just like a medicine capsule, no? So encapsulate in some sort of a gel, and then it is protected, and you can transfer it at your own convenient time, whether you go by ship or by railway or by plane or by car. Go ahead, take time. You can take 3 months, 6 months, depending on the supply and demand, no? So do you realize now why we need to encapsulate these seeds, these somatic embryos, okay, these artificial seeds, so that we can use them to manufacture different drugs, different medicines, no, that are otherwise would have been too costly just to go all the way to Brazil, and pluck, right? Okay, so let's see. Let's see what is the procedure. The procedure is to mix the somatic embryo in a substance to make it well protected in that matrix, and it is rigid enough to allow for rough handling, okay. So I've given you that story about the ship and the airplane, transportation. So the artificial or synthetic seeds are this seed-like structure where the somatic embryo, means that artificial embryo, that part of the leaf or stem or shoot, whatever, that is taken from the tissue culture. They are covered, they are encapsulated by hydrogels, okay, hydrogels, and can be used directly to be sown in the soil as a substitute for the natural seed. Okay, so I think it's more than clear enough from my explanation. Okay, now let's look at the diagram. So looking at the diagram of this artificial seed, okay, you see that embryoid. So maybe that is a part of the, let's say it's a part of the root. They cut a part of the root, it looks like that, no? And then there is one synthetic endosperm, artificial endosperm, that we have mixed with certain chemicals, no? And in that endosperm, it's just a lab condition only. You mix those micro and remember those micronutrients and macronutrients, no, that you studied from class 8. I think you already studied, no, micro and macronutrients, then vitamins, then agar, then carbohydrates, and what else, amino acids you add. Okay, you add those. It comes in powder form, no, those micro and macronutrients. Then you mix it well in one, let's say in one beaker. Mix all the micronutrients, all the vitamins, all the amino acids, etc. You mix, you dissolve it, you add some agar, and there is your artificial endosperm is ready. Okay. Just like the natural endosperm, no, that we will be studying about endosperm, I think, in the other paper. So just like the natural endosperm that helps the seed, that gives the seed a nutrition, okay, to survive when it's inside the seed coat, same way that this artificial endosperm, it will provide with the necessary nutrients to that artificial seed, that embryo, that somatic embryo. And then you can see one seed coat. This is also some gel-like substance, okay. Some gel-like substance will form, okay, to make this seed coat. Where did I reach? Okay. Now this artificial seed, they will germinate normally into plants. So this covering, it will give the physical protection and avoid drying out, and it will, and that capsule, no, that gel, it will have the nutrients, the growth regulator to help in the germination. Okay. Sometimes they may add antibiotics so that even if somehow, if in the lab also we may make mistake, no. So if somehow in the lab there is some contaminant, it will, the antibiotic, it will kill it off. Now here are some difference between the natural seed and the artificial seed. This one you go through by yourself, no? Like natural seed has a hard seed coat, then it has cotyledon, endosperm, etc., etc. Then in the synthetic seed, there's no seed coat, no, only some sort of a capsule is there. Okay, you go through this one by yourself. You just, I'm more concerned about your concepts, no, about concept building. So there again, that's the difference between the natural and artificial. Now let's look at how to create these artificial seed. Okay. Okay, directly we will look at this, the experiment, okay. So you see, you start with a part of the plant, whether you take a leaf, whether you take a stem, it is your choice, okay. Which part you want, it's your choice. It's the choice of the scientists, okay. If it's easier to cultivate, to grow using a stem, so you take the stem. If it's better to grow with a leaf, you use with the leaf. That one, it comes when you perform the experiment. You will notice that certain parts responds better. If you want more flowers, maybe you prefer to take from the stem. Like, because certain plants behave differently, no? Okay. So this is your choice. You take the leaf or the stem or the root, aapka choice. And then, okay. Then, what happened? Okay. Then you have to clean that part of the plant, okay. So you surface sterilize it. Remember I told you, you wash it with some sort of a soap known as sodium hypochlorite. You wash it. Then you rinse it with distilled water 3-4 times. So our plant is already sterilized. Okay. Then you put on the solid medium. Okay. Remember that agar type? Miss Rimaya and Miss D and me, we have made a video for you about tissue culture, and you will understand looking at the video. Okay, when it's time, we will upload it, and I think it will be clearer, the practical. Okay, so you place it on the solid medium, or it's depending on you. You can place it in a liquid medium also if you have so many. You want to cultivate so many. Like you are working in an industry, you have to produce lots of medicine. So you can put in the liquid medium where you can keep many plants. Okay, many eggplants. Explant, EXPLANT. When we this word explant means when we excise and take a part of the plant, that is an explant. Okay, it's not yet an embryo. Not yet. It has not become an embryo yet. No. Still an explant. So if you are working in a laboratory, you will do only a few. No, you'll put on one solid media because you're just maybe you're studying how it behaves according to light or temperature. It's your choice. But if you're working in an industry, you need lots. So they're keeping it in a liquid medium. Then remember, I said the callus. So if you don't, if you don't give an auxin or a cytokinin, it will not know whether it should produce roots or shoots. So it will just produce cells. Okay, cells are callus. Okay, then this callus, it is your somatic embryo. This callus, it has all the information ready. Okay, ready to take direction from you, whether you want a root or a shoot or a stem. Okay, it is a somatic embryo. It has all the necessary information. It is just waiting to get the direction. Then now this callus has formed, no? So you divide this callus into different parts, and then you put all these small parts of the callus, okay? Because this has become your somatic embryo, okay? Remember I told you this callus, it has all the information ready, okay? It is just like the zygote, no? It's the zygote which has all the information of the father and the mother, and it's ready to divide. Okay, it's just waiting. Okay, it's just resting for some time, so that there is no. It is just rechecking, so that there is no problem. Okay, so this somatic embryo, it's just like your zygote embryo. It has all the necessary information, and all is correct. Okay, if there is some problem, if there is some defect, it will automatically decline itself. It will automatically die off, and keep only the good parts. Okay, so this somatic embryo is ready, and then we have to put it in a solution of, can you see there, girls? Sodium alginate solution. Okay, so this one has sodium alginate. Okay, this beaker has a solution of sodium alginate, so they just drop all the callus in there. Then what do? You take a dropper and you suck out the embryo. You take a dropper, okay, and you squeeze and you squeeze and you let go, no? So this embryo and little bit of sodium alginate comes up, isn't it? Yeah, it's just basic, physics. So, and then that dropper which you have taken, which has sodium alginate and the embryo, what you do is you drop them one by one. Can you see here? You drop them one by one in a calcium chloride solution. So you drop in one calcium chloride solution, and immediately in 1 minute only, in a snap, you will see as soon as the sodium alginate and the embryo, they fall into the calcium chloride solution, immediately a capsule will form, because this sodium alginate and calcium chloride, they will interact with each other. Okay, so sodium will go with chloride and alginate will go with calcium. No, it's basic chemistry, right? No, so as soon as that sodium alginate with the embryo falls into your calcium chloride solution, it will immediately form a capsule, okay? Because the calcium and the sodium and the alginate and the chloride, they react with each other. Then, since it has formed, that capsule has formed, so since the capsule has formed, again, what is going on? So since the capsule has formed, now they are ready. They have become your artificial seeds and they are ready to be transported wherever you want them to go, or they are ready to be sown in the field wherever you want them to sow. Okay, but when we say sow, I mean you sow them first in the lab. Okay, you take them first in a media which has auxin and cytokinin, to create roots and shoots. Then when the root and shoot form from the callus, then you take it into a nursery with a small cup of soil and cow dung and charcoal, whatever you prefer. Then when they have become strong enough, they have hardened, transfer them to the field. Okay, so I hope the steps are clear for the process of artificial seed formation. Okay, if it's not clear, I encourage you to look at some videos on YouTube. It's not that Miss Amy's word is law. It's you should always broaden your knowledge. Okay, I may be able to explain to you, but what if you are not able to catch my words? You can catch somebody else's words. I don't mind that. If it's not clear, then you can just see one video. Those cartoons, they have made, what do you call it, animations. That will be even more clear. But if it's clear enough, then don't waste your time, because nobody wants to learn extra things. No, I mean, it's so boring to keep learning the same thing again and again. Okay. So I think my explanation is even better than what they have written here. Okay, so I've explained in such a way that it is easy for you. From the image only you can explain. Okay, now just look at the uses directly. I'll just read out a few. You can read out the rest on your own. Why I have to read like children, no? I think your concept is clear, how we made it and why we need it, and what it is. Okay. So there are some uses here. Some plants, they reach the reproductive stage very late. So, and when we need them in a short time, synthetic seeds are more helpful, okay, rather than waiting for the plant when it will flower, then when it will fertilize, then when it will fruit, then when the fruit will form a seed, oh God, then when that seed will, the rest phase, then when after that seed will germinate, then whether the germination, whether it work or not, oh God, just thinking about it, I'm already tired. Already, I'm tired of waiting. Because I'm the impatient type of person, no? Okay. And so for those plants that have a long reproductive phase, artificial seeds, they help to reduce, the time period. And then another use is that you don't have to depend on the season. Some plants, they flower and they fruit or they seed only a particular season. But using somatic embryos, using artificial seeds, it doesn't depend on the season. You can produce them throughout the year. Okay, if you need it, you can produce throughout the year. Then there are some seeds that have a dormancy period, no? So to overcome the dormancy period, they have to wait that amount of months. So to remove that dormancy wait, you can use artificial seed directly, when it benefits you. Sometimes even in certain plants, like orchids, yes, they do fertilize. Yes, they do produce an embryo and then a zygote. But the nature, it doesn't suit it. It dies off. That embryo, it dies off. No, even in humans, sometimes it happens. what is the term? Oh, I forgot. Sometimes it happens, that the embryo just dies off. It doesn't have, the maternal flower cannot support it. So to reduce this embryo death, you can just use your somatic embryos. Okay. Then sometimes after the embryo, it has survived. Then even when it has survived, to grow it is difficult. It needs so much, care. You have to keep it in the nursery for so long. No, you have to keep monitoring it. It's just a waste of time, right? Because it's a plant. No, why you have to waste so much time? No, and suppose it's an important plant that you need to produce quickly and sell in the market. It's just a waste of time, right? So in that case, where the embryo, it germinate, but it failed to grow. So in that case, you can use the somatic embryo quickly. So the rest of the uses you read on your own. Okay, so I stop here and I'm uploading it.